Hello everyone, this is Robert and this is the Carvera Air. Have you ever wondered how an itty bitty little desktop CNC machine like this can handle machining aluminum? Well, that's exactly what we're going to find out in this video. I've got this block of aluminum and we're going to machine about 75% off of it. So let's see how it does. So full disclosure, Makera did reach out to me and send me this machine for free in exchange for the videos and the content that I'm making. I didn't accept any money. I don't have an affiliate link down below. I just kind of wanted to see what these desktop CNC machines are all about. I've been seeing them advertised everywhere, whether it be like the Nomad from Carbide 3D, the Carvera. There's a lot of them out there, and this one looked really interesting to me. So I figured I'd pick it up and kind of run you through a sample scenario of what it would be like machining aluminum. So we're going to take this cube and turn it into kind of a pseudo Turner's cube, and that means removing about 75% of the material. So we're going to be doing a lot of aluminum machining on this today, and I want to show you the full process from the cam all the way into each one of the operations and the setups. And it'll hopefully give you a little bit better idea what this machine is about and what it can do, and what it's like to kind of interact with it. I'm going to eventually be doing a full review of it, but for right now, I just kind of want to use it and get to know it a little bit better. So let's start with the cam. So here we are inside Fusion 360. I'm going to be using this for the cam since that's probably the most common cam package out there, and Carvera works really well with it. As you can see, if we look at the setup, the machine is already in here. You do have to load it, but you can download this configuration file from their website, load it into Fusion 360, and then this makes life a lot easier. It even has the post processor and everything, so that is nice. This is our model. I actually created this in SolidWorks, import into Fusion, just so it was a little bit easier for everyone. And if we look at the setup once again, you can see that I'm doing no additional stock. I already have the piece of aluminum cut down to size because it's just going to make life a lot easier. But you can see that this is going to be my origin, is that top left front corner of the stock. Cool. So over here we have all the tool paths. I've got a 3D adaptive clearing that will clear out all of the little faces here. Now, this is a 6-sided cube, so we're basically just going to be running these operations 6 separate times. So I'll run it once, rotate the cube, run it again, rinse and repeat 6 separate times. For the adaptive clearing, I have a tool selected. I've got an 1/8" end mill, which is one of their tools. They do provide you with a tool library, which is pretty cool. And the other nice thing is, with those tools, they already have presets for all the speeds and feeds. So I'm selecting this 12mm single flute end mill for a metal, and I select aluminum, and then all the feeds and speeds come along with it, which is really, really nice. They're aiming this machine at beginners, so providing you with those feeds and speeds for the machine is wonderful. The only thing that I changed is I increased the maximum roughing step down from 0.2 to 0.225 because this thing's going to take a while, so I'm just trying to speed it up just a little bit. For the stock to leave, I'm leaving 0.1mm on the radial stock, but I'm cutting all the way down on the axial because it should be just fine. Then I'm doing a couple contours to clean up those passes. I had to do a separate top and bottom just because of the way Fusion is seeing the geometry here. So I did one for the top, one for the bottom, and then I'm repeating those passes just as kind of a cleanup pass to get a better surface finish. And then finally, I'm ending the whole thing with a chamfer. I'm doing the chamfer separately, obviously with a separate chamfer tool, because I'm not going to be watching this machine for the entirety of the operations. So when it finishes, I just want to swap in the chamfer tool manually and run it. You could absolutely run these all as one, and the machine would just prompt you to change the tool. But I don't know, maybe I'll be doing something else, so I'm doing them separately. So here's where we can start to see the limitations of the machine. So if we click on Setup and go to Actions, Simulate, and then click on Statistics, we can see that the total of these operations is going to be about 48 minutes. It's going to be a little bit longer than that due to just some errors in the simulation, but it's going to be about an hour for each one of these faces. So that means if I'm sitting right at the machine and right there to take out the tool, put in the chamfer, run that program, flip it around, go to another face, hit go, it's going to take about 6 hours in total machining time. And that is just the downside to using a small bit with relatively small step downs and small step overs. Even though it's going to be moving relatively fast, it's just not able to remove that much material. It's doing this because it's trying to preserve as much rigidity as possible, and also the spindle is only 200 watts. So for an 1/8 inch end mill, it's probably going to cut just fine. It's just going to take forever. I mean, we can speed this up. It's got a lot of work to do, and with that little end mill, it's going to take a while. And this cube is only 37 millimeters, so that is the downside to a small machine like this. Let's get it set up. Okay, so we're inside Carvera Controller, so now we need to load the file over. Unfortunately, they don't have a mapped network drive function, so you can't export directly to the machine, so you have to use an intermediary. You can save it locally on your computer and then copy it over, or use an SD card like I'm doing here. So we just click on Upload File, select the clearing program, and hit Upload, and it'll take a few seconds. I did communicate to them that it'd be really cool if there was a network drive option where you could just map it on your network and export the file directly over. They're looking into it in theory. It's not a big deal, but the files do run locally from the machine, which is kind of nice. So the computer or the controller that you're using, you can use a phone or a tablet, really doesn't play the file to the machine. The machine is loading the file locally, which is kind of nice. You don't have to have the computer on. If something gets interrupted, it won't cause an issue. So we're going to hit close. Now we have the cube clearing file. We're going to go ahead and hit select, and this will load it into the controller. And there it is. So we can see the tool path. We can even kind of double click. We can zoom in. And then you can even do kind of a simulation preview of the tool path right there. So pretty cool stuff. The controller's, pretty decent, has all the basic functionality that you would want. So the next step is to set the origin and actually run this file and start making some chips. So as you can see, I've got the aluminum block mounted in the machine. It is in this far left corner, and I have it secured with toe clamps. A vise would be a little bit nicer here, but this is what it comes with, and it should be fine for this operation. I have the spindle centered with the origin where I want it. I use this little touch plate that is included to get to that origin. I did this off camera because you kind of need to interact with the machine, and I was just right in front of it and in the way, so I didn't get any good footage on it, but it's fairly simple. So now that we have this as X0, Y0, we can run the program, and that will go ahead and set the Z height as well. So from our controller, we can go ahead and hit run, and this is the program that we loaded. For the work origin, I'm not going to reset it. I'm just going to keep it at current position, which is just 0 and 0. So we're going to hit OK there. We don't need to scan the margin because we already know what our work looks like, but we are going to use the Z probe, and I have this set as 2 millimeters in from the corner. I have it set like that because when we rotate the face, we're going to be starting to remove stock, so having it 2 millimeters in is a good position. So we're going to hit OK, and when we hit run, it should do everything. So it wants us to load the little Z probe, which is located right here in the head. So we're going to pull that down, mount it in the machine, hit confirm, and it touches the tool setter offset, so it'll get a height on it. And then it'll come over here and probe the work. And 2 millimeters in and 2 millimeters up, just what I said. And this little quick change thing is pretty slick. And now we load the actual tool, hit confirm, and we should be good to go. It's going to once again hit the tool setter so it gets a relative offset to the probe. And I'm going to close this. So I am cutting this part dry. Coolant would be nice, but unfortunately there's a couple of reasons I'm not using coolant. The first of which is this machine doesn't have a way to actually spray coolant on the end mill. The second is the bed surface is MDF, so any liquid is going to be a bit of a problem. It does, however, have a little air nozzle with an air hose hookup. I have that connected to my compressor. I have that turned down to maybe 20-25 psi, and there's a nice air blast on the end mill. That will help cool it, and it will help get rid of the chips. For deep pockets like this, just having the chips accumulate at the bottom is the worst. And if you're just kind of using like a fog buster, I've seen that the chips will just kind of stick to the bottom of these pockets, so running it dry is actually kind of better unless you're doing full flood coolant, which this absolutely does not have. So the first operation ran, everything looks pretty good. So now I'm going to run the chamfer, and to do that, we're not going to move the origin. So we're going to go into the MDI, we're going to do G0X0Y0. This will move the bit to the origin. Cool. Now I'm going to load the chamfer program, and in the work origin I'm going to say current position, which is where it is right now. Hit OK, Z probe still, good, 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 and hit run. And this is why I set that offset at 2 millimeters, because otherwise it'd try and go in the middle of that pocket that we just machined. So it should be good. The little laser shows exactly where it's going to be. Okay. So now we swap out the chamfer bit. We should be good to go. This will only take about a minute. Go. So the first face is done. That took about an hour. So now I'm going to loosen these, flip it around, and just rinse and repeat for the other 6 faces. Although this type of work holding is very convenient, it's really not that rigid, and I'm definitely not getting as good a surface finish as I would expect from this machine, and it's probably due to a lot of factors, but the work holding is part of it. Toe clamps are decent, but it's screwing into this kind of MDF board, and you can really only screw them down so tight, and when you screw them against the side face of the cube, once you get to a certain point, it just starts pushing the actual toe clamp back. It's not secured down into the bed tight enough for a really rigid setup. Once again, it works fine for this, but a real vise would make this a lot better. So while I wait for the other faces to get machined, let's talk about a few things. So why didn't I prepare the stock on the Carvera Air? Why did I do everything on the Tormach? Well, as I just talked about, this machine doesn't really have a vise, or I don't have a vise for it. And squaring off stock really kind of requires a vise. You could do it without. I have a link down below to a really good video from this old Tony about how to square off stock. And this machine just doesn't really have all the right tools. You'd need a proper vise, probably a 1/4-inch end mill, or at least some kind of fly cutter, and a lot of patience. And I really don't have any of those. I guess I have a 1/4-inch end mill, but realistically, with an 1/8-inch end mill, it's going to take you forever to face anything off, especially with a really small depth of cut, and there isn't a vise to be able to hold it in the proper way to square it off. So I took a couple shortcuts and just used the vise on my Tormach and a fly cutter. So this kind of operation just really isn't suited for the Carvera Air. So I'm on the last and final face of this, and I just kind of wanted to give you an idea what it sounds like and what it looks like when it's cutting. I'm using my phone on a gimbal since it has a lot less noise reduction. So I'll kind of get you an idea of the audio here in a second when it plunges down. So it's definitely not quiet. It's a lot louder than the loudest 3D printer you could ever imagine. You could maybe use this in an apartment, but if I was your next door neighbor, I'd be very upset with you. But in a spare bedroom with the door closed, I think it'd be fine. In a closet in the spare bedroom with both the doors closed, I think you'd be okay. This should give you a good idea of how many chips do escape the enclosure. Keep in mind I have been lifting this up and down quite a bit through this process, but a lot of chips do find their way out of it. There's also a lot of them underneath because of these little slats for the guide rails, but that should kind of give you an idea of just the kind of mess and the noise. The spindle is sitting at about 42 degrees Celsius right now, which is a little over 100 degrees Fahrenheit, and it's been running for about 6 hours continuous. So I'd say it's doing pretty good. No hiccups, no issues. So yeah, that should give you a little bit better idea of what it's like when it's actually running. I'll be back when this is finished. And after 6 hours of machining, here is the finished cube. Overall, it turned out really good considering what this machine is. Yes, it took 6 hours. Yes, there's a lot of chatter and the surface finish is not very good. But this machine weighs 30 kilograms, or about 65 pounds, and costs between $2,000 and $2,500. For a desktop CNC machine doing aluminum, it did a pretty good job, all things considered. I think if you had a real vise on this, you could get a lot better. And if I went and optimized the tool path a little bit more, I did the contours as a full depth. I probably could have done a stepped depth and then just done one pass all around after that was done. There's definitely some optimization to be done. But overall, this started out at 140 grams, and now it's down to, I think, like 30. So that was a lot of material removed, relatively speaking. I think for small parts like this, the machine does a pretty decent job. I'm curious to see what else it can do. Wood and plastic, probably be very, very easy. The bit, Looks really good, not a lot of wear, very, very sharp on the end. I'm saying that because if this was just rubbing the whole time, that tip would be dull. The tip is still perfectly usable. This is has a lot of life left in it, and at no point was this ever warm. It was barely room temperature, so it really wasn't doing any rubbing. It was actually making real chips. These are actual chips. They're very, very small chips, but they're chips nonetheless. So overall, I think the machine does what it's supposed to do, but the bigger question is a desktop CNC machine really viable? Are you really going to make parts out of an 1/8 inch end mill? That's up to you to decide. I'm going to do a full review of this later, but I don't know, I'm pretty happy with how this came out. It did the thing. So as always, thanks for watching. See you in the next video.